Wake up.
Matan ka talaga dito ah.
Oo.
Okay, game. Sige, start na tayo para mabilis kasi mahaba-habang paliwanagan to. So, off na yung mga mic nyo guys. We're gonna start na. So, yun. Good morning guys. Uh, so, ako lang to, si Patrick. Ha? Parang nang sa car wash ang putik. Di- Sige, mamaya na mag-alak dyan. Discuss muna tayo. So yun, ako nga pala si Patrick Caperal, intern third year na ME. So I quizzer sort of. Di ko lang ako former or current, but let's see. Basta yun, I was a quizzer, but I don't know until now. But let's see. So ako ang magtuturo sa inyo ng physics. Physics for engineers nyo. So, para sa mga freshies, this is basically an overview ng kung ano mang maharap nyo this first year, second sem nyo. And this is kind of ano, a higher level na physics na rin. Kasi we will expand on what you have learned from your senior high in STEM, in general physics, 1 and 2. While for the sophomores naman, narinig ba ako?
Pakilakasan po yung boses. Salamat
Okay,
po.
sige. Oh, sige. Sige, sige. Ngayon, for the sophomores, this is basically your crash course talaga since the pandemic happened and yun, things got a lot messier after that. Tapos, ang sabi sa akin ni Press ay hanggang forces lang yung natakal nyo. And which is basically yung isang buwan pa lang kayo sa physics. So sa isip ko, medyo talo kayo this sem. Pag hindi nyo na-cover yung mga kailangan nyo this second year, first sem. Physics dependent ang karamihan sa mga courses nyo na. So, yun. Let's begin. So yung part 1 natin this morning, we will discuss two conditions ng equilibrium for the isa sa force, saka isa sa moment. Kinematics, yung walang kamatayang kinematic equations and free falling bodies. Tapos yung lagi natin kabisadong F equals ma na law of acceleration. Can follow pa? Nakakasunod pa rin? Kaya guys?
Apa,
Nakasunod.
nakakasunod po.
Okay, okay sige, sige. Game. For first one, we will discuss yung first condition ng equilibrium. This is just pinaka-complicated na pagka-classify lang ng info, pero this is basically,
Sir, medyo mahina po yung audio.
sige. Wala, di pa nagsasalita ngayon pa lang. So, ayun, basically, the first condition of equilibrium, it is based on Newton's law of inertia and law of reaction. So, yung first law and third law ng Newton's law of motion. So, I feel like you remember this, ito yung unang topic sa physics, yung summation of forces acting upon an object in equilibrium is equals to zero. Sigma F is equals to zero. Wait, teka lang. Ayusin natin to. Teka lang ayusin natin. Teka, ayusin natin to. Malakas ako yung boses ko Good. Narinig na rin ako? Okay na?
Apa, okay na parinig.
Okay. So
Yes.
going back,
Okay na po.
nice ko lang yung settings ng PowerPoint. Anyways, let's continue. Basically, ito yung unang topic niya sa physics, which is yung summation of forces equals to zero. Is equilibrium, obviously. Ito yung unang topic talaga, but we need to know these two terms that we will use them later and lalo sa analysis ng ating mga free body diagrams. Una, yung line of action is a line of indefinite length in which a force vector is acting along. Basically, let's say this is a point here. This point of concurrency kung saan nagmi-meet lahat ng forces. Let's say you have point acting here, point acting here. So basically, this one right here, this one right here, you can extend it up to this point. Yun lang, simple. I know it's still confusing at this point, pero later on, we will see how this will play out sa ating analysis ng problems. Next one, yung concurrent forces. Forces whose line of action intersect at a common point. So basically, ito nga yung common point ng intersection nila. And at this point, itong point na sinasabi is literally a point sa analysis natin, but this point could be assumed as just a particle, as small as a particle or as big as a car. This is our way of assuming, of simplifying problem solving, lalo na pagka malakihang problems na involving real life situations. Yan. I didn't really want to expand it that much, pero let's proceed. So, recap lang tayo sa first law of motion. So, law of inertia. An object will remain at rest or will continue to move along a straight line at a constant speed unless it is compelled by an unbalanced force. Medyo complicated lang, di ba? An object at rest will remain at rest, but an object will continue to move along a straight line at a constant speed unless acted upon by some force. Medyo familiar naman na tayo sa law of inertia, no? Inertia, what is inertia about? Inertia is the property ng isang matter to persist in its original state of motion. Medyo simple pa. Medyo kaya pa. Medyo naalala pa. Ngayon.
Yes.
Okay, third law. Yung pinakamadaling law na tandaan actually, yung action-reaction thingy. For every action, there is equal opposite reaction in simplest terms. Pero we're in college na, so we have to expand that definition para ma-apply sa ating problem solving. Ngayon, yung reaction force natin ay mas specified na equal siya in magnitude but opposite in direction. Itong third law na to, ang dahilan kung bakit meron tayong normal force sa mga problem natin. Yung, let's say, this is a block acting in equilibrium, is sitting at the ground. So, the block is acting upon the ground via its weight. At the same time, the ground is acting upon on the block. This is the normal force. Kuha? Kasi equilibrium.
Apa.
Okay, so medyo naalala pa to. Medyo ito yung familiar ground natin. Pero with all this, meron tayong isang force pa dapat na fini-feature dito, which is yung friction. So friction, it is the force between two surfaces that are trying to slide across each other in the direction opposite of the motion. Because, natin explain to. Simple. Yeah. So if your motion is here, since friction tends to slow down or prevent something from moving, it tends to increase the force necessary para lang mag-move yung certain block. Ngayon, if we think of friction, we always think na it's based on the rough edges. Mas rough, mas malaki yung friction force. But we have to account din kung how hard yung dalawang surfaces are acting against one another. That's why ang formula ng friction is the normal force and the coefficient of friction. It is yung if normal force, if you remember, is yung reaction force ng second surface of first surface. Kaya ang formula natin for friction is coefficient of friction, symbolized by the Greek letter mu, the normal force, friction force. May two types tayo ng kinetic friction, sorry. kinetic and static. With kinetic friction, this one tends to slow down the motion. So ito yung point na yung familiar tayo yung sa gulong. Yung gulong, yung motion niya pag ganyan, the friction force tends to be this way. Pinapabagal niya, I mean, it prevents skidding lalo na pagka yung surfaces ay wet, lalo na sa asphalt pagbasa or yung or cemented. While static friction, as the word static implies, something that's not even moving in equilibrium, is the force that is needed to be overcome para lang mapagalaw yung certain object. Let's say this block right here, right here. O burahin natin lahat to para burahin natin lahat ito. Yeah. Let's say we have this object here na tinutulak mo ng kamay mo and it still doesn't move. Let's say ground. But it still doesn't move, which means that the static friction of the static friction, the force needed to get this object moving is bigger than the force of your hand. Pero if you try two hands, it begins moving, which means that you have overcome the static friction and kinetic friction goes at play. Later, makikita natin kung how static friction and kinetic friction will play out in some problems. But right now, let's proceed with the first sample problem. Kaya?
Try.
Yes po.
Try. Ready na yung calculators nyo guys and yung sketch papers nyo because I want you to sabayan ako sa pagbuo ng free body diagram. And sa later on kasi meron na itong mga calculator techniques which for sure medyo malulula kayo sa una pero by the time after this sem at medyo nag-grasp nyo na yung idea ng calculator techniques, it will save your life a lot of times dito sa engineering game. Ngayon, this problem is from a statics book. Statics book namin. Don't worry. I mean, kaya to solve ng physics like using physics lang natin. But ang nagpa-complicate lang talaga dito is meron siyang specific measurements. But anyways, kaya natin itong isolve. Need to put our mind and heart into it. Anyways, the device shown is used to straighten the frames of wrecked autos. Determine the tension of each segment of the chain, AB and BC. AB and BC. If the force which the hydraulic cylinder DB exerts on point B is 3.5 kilonewtons as shown. Okay, let's try to do the free body diagram here, okay? Una, tension force. You're familiar with tension force as a force that pulls away from the, the point of concurrency. And this 3.5 kilonewton force, this is, we can draw a line of action extending this force right here. Kaya pa? Nakukuha pa kung how we're going?
Apa.
Okay. So, lipat tayo dito. So, we have an horizontal force, AB, point of concurrency. We have here. We have a right triangle here involving 450 and 250. So, let's draw a right triangle here. So, that's 250 and 450. And then this one involving 400 and 450. Kaya dito manggagaling ang ating angle that we will be using later. This is the physics way of solving this, pero in statics you will be taught of vector rotation, which is kind of similar to this, pero make it a little bit more complicated. Nakukuha pa? Para ba tayo ng free body diagram?
Apa.
Okay, let's make this drawing a little bit clearer with this one. Yeah. Para mas madali, para consistent tayo lahat, we will be finding the angles with respect sa x-axis. So this one, and this one. By principle, this angle is corresponds sa right triangle to this one. And pag ito naman, tinignan natin, this one. This is the angle. This is congruent, and this would be the angle of talking about. Para mahanap natin yung angle at the 3.5 kilonewton force, we have angle alpha, which corresponds to our tangent. We use tangent most of the time, madalas sa pagbuo ng ganitong equation. Opposite over adjacent. Do you remember? If you still
Yes,
remember, good. Gagamitin nyo lagi, madalas yung gagamitin ito. Kaya, let's go. Arc tangent, 450 over 400 angle. And then this angle beta equals opposite of 450 all over 250. We have sagot na angle. Nakuha?
Opo.
Yes po.
Kaigo pa lang tayo, wala pang physics ha. Let's go
Opo.
first. Let's begin. We look first into the component forces nitong 3.5 and yung force BC. So, we have here, here. So let's put this one as the 3.5 kilonewton and this one force BC here. Ito, yan na. Basta, gets nyo na yan. I'm just drawing the component forces nito. Upward. Yan. Ngayon, let's look at forces along the X. Since ang titignan natin ay isang system in equilibrium, the summation of force, we apply the first condition na yung summation of forces are equal sa zero. Yan. With assumption natin, we're assuming na ang upward direction and the rightward direction ang positive direction. However, kung gusto niyo naman ng downward or right, magkaroon kayo ng variation sa positive sign nyo, it's up to you. Basta as long as you're consistent in applying assumptions sa problems nyo, you'll be fine. Looking at the forces along the x-axis, we have force AB, the x-component ng force BC, and yung x-component ng 3.5 kilonewtons. Force AB acting on the left, so we have negative. Then the 3.5 kilonewton force acting along the x-axis, this is our angle here, and this is our hypotenuse. Our x-component lies on the adjacent side. That's why we use cosine. Naalala pa si Ka? So katawa?
Yes po.
Okay, so we have 3.5 cosine alpha. Ngayon, yung force BC naman natin is this one. And our x-component acts on the adjacent side, so we use cosine beta. Force BC cosine beta equals 0. Since gagamit tayo mamaya ng Calcutech app, make it a practice that your constant, this one, your constant number is at the other side of the equal sign. Titira nyo lang sa kabilang side ang force AB and force BC dahil these are the two variables na kailangan natin na sagot. Yan, I'm giving you tips on Calcutech para ma-practice nyo na rin. Gawin nyo na rin practice yung paglilipat sa isang side nitong constant term. Dahil para mas masimple natin tong solving process. Now we look at forces along the y-axis. First condition of equilibrium, so equals to 0. Our upward force is a 3.5 sine alpha, and our downward force is yung y component ng force BC. Then, hiniwalay natin tong 3.5 sine 48.6665, itong y component ng 3.5 kilonewton force sa isang side ng equal sign, and yung force BC ay nasa isang side. Nakukuha? Nakuha pa? Because we're going to, to do calculator technique na.
Nakuha po.
Okay, so paki-ready na yung calculator niyo, guys. My calculator kasi is Casio 991 ES. Paki-ready na yung calculator nyo. And if your calculator is the same as mine, FX991ES, you can proceed at this part. But if not, this is medyo exclusive to for calculators na ES who can solve two equations to unknowns. If your calculator is EX, meron diyang sa menu, you'll find the polynomial. Yeah. Basta gets nyo na yun. That. And then, tatanong sa inyo kung ilang unknown variables from 2 to 4. You answer 2. Our two variables are force AB at force BC. Ngayon, what we do is that we type the coefficients ng mga variables and yung buong constant term sa isang side. Because this is the format na sinusunod ng ating mga calculator sa pagsosolve, might as well practice doing making the final equation similar to this one. Shall we continue? Kaya pa? Kaya pa, guys? Okay, ito muna ang equation na to. Ito muna. We have the force A. We assume na yung x natin ang force AB and yung y natin is yung force BC. Ngayon, at this equation, this one, our force AB's coefficient is equal to 1. And our force BC is equal to negative. We take the negative sign and then the cosine. Negative cosine 60.9454. And then our constant term will be at C. At the column C. Nakukuha? Natatype pa? Nakasabayan ako? Or meron pang mga calculator na nahihirapan?
Wait lang po.
Sige. Sabihin niyo if pinatype niyo na, then we'll continue with the second equation.
Okay na po.
Okay, for the second equation, we have this one. We don't have FAB, so we have 0. But we have FBC, positive sign 60, and then our constant term. Pag na-type nyo na to, anim na numbers na ito, press equal. Don't press a double equals kasi it assumes that you were finished with typing your equations. Paki-check kung tugma tayo ng sagot. Tugma ba tayo, guys? Nakuha ba? Or may tanong pa? Tugma tayo. Paki-type na lang sa kung tama tayo ng sagot. Or sige, mic nyo kung tama tayo ng sagot. Bago tayo magtuloy.
Kap, may tanong lang ako.
Po, tama po yung akin.
Sige. Teka. May tanong?
Ayun, wait lang, Kap.
Sige.
PM to. Nagigets ba nung lahat ng sinabi ni Kap tungkol sa calc technique or mas maganda kung ipakita ni Kap mismo, parang i-on cam ka na?
Mas prepare po siguro ng on-cam.
Try siguro, Kap. Thank you.
Wala akong webcam
Wala ka bang webcam?
Wala akong webcam, guys. I'm sorry. Yung kakahapon meron Yung dito wala. Pero di naman sila nagtanong about sa calculator technique. Kuha nila yung agad. Sorry, guys.
Kasi guys.
Kaya pat-help na lang JM sa kung kaya mo ba? Sa'yo?
Nasa ano ako eh.
Okay. Sige.
Nasa trabaho ka.
Okay. Sige.
Sino ba dyan?
Sasend ko na lang ng video dun sa calculated technique part.
Si Dan siguro.
Patry nga. Kung kaya niyo gawin.
Ako ba?
Oo, Dan, ikaw.
Wala, may calcio ko.
MS ba yung calcul niyo?
Hindi.
Sino yun? Yung sumasagot kanina.
Yung other second years siguro. Ang mga second year.
Second year, dapat be responsible dahil para talaga sa inyo itong calculator dahil iligtas talaga kayo nito. Or Louis J, baka kaya may turo din yung calculator nito.
Louis.
Malabo po yung camera.
Okay. Ganito, since di natin talaga ma-address yung calculator nito ng ayos, we have to mamaya, second part, kung tatry kong lumipat ng PC, kung may webcam para mapakita sa inyo ng ayos. If not, if talaga hindi, we'll send na lang ako ng video ng calculator, ng problems na na-applyan para sa convenience ng lahat. Both batch 1 and batch 2.
Yan, salamat, Kap.
We have to continue talaga kasi we have a lot of topics to cover. Okay, guys? Kasi sa physics nyo, ang di tuturo sa inyo itong calcitech, ang tuturo sa inyo is yung mano-manong pagsosolve ng problem na ito. Let's say, balik tayo dito. Let's say, ang gagawin sa inyo is that you will find FBC by dividing this dito sa equation na to. So, magiging 3.5 yung sine 48 over sine 60 equals yung sa FBC, force BC. Yun, may sagot kayo. Yun ang tuturo sa inyo ng solving sa physics. Pero this is time consuming kasi susulat nyo pa. And sa statics, hindi na kailangan yung ginagantong process as long as alam nyo, tama yung concept nyo, at nakarating kayo sa format na AX plus BY equals C, you'll be fine. Once nakuha nyo itong sagot in the way na physics are solving it, ipapasok nyo itong sagot dito sa first equation. Then you will get an answer for FAB. Dun sa mga nakapagtugma ng sagot, I'm glad that you did. I'm relieved. But you have to continue kasi itong matrabaho next problem. It involves the second condition of equilibrium. Ito ay applicable lang sa rotational equilibrium. So basically, patalan natin yung forces ng torques or moments acting on an object equals to zero if in equilibrium. So ano ba yung torque? It is the measure na effectiveness ng isang force applied on a body producing rotation. Effectiveness, let's say this is a point of rotation and a force is applied that produces a rotation. It's madaling concept na i-grasp dahil we can see this working lalo sa mga tools. And our formula for torque is torque or sa physics moment equals force times the lever arm. This lever arm is the trickier part sa analysis ng ating problems involving torque. Because lever arm is the perpendicular distance, this one, perpendicular distance from the line of action of the applied force to the point of rotation. So the lever arm involves this one point here up to this point right here. This is our lever arm and force. Can follow?
Apo. Kuha po.
Okay. Sabi kasi ni Pres sa akin na na-touch siya daw to, pero let's see kung if you still remember. Itong problem na ito ay galing sa aming physics. A 20-meter long ladder weighs 40 kilonewtons. It is leaning against a rough vertical wall, making an angle of 60 degrees with the ground. The center of gravity of the ladder is 8 meters from the bottom end. How far can a man of weight 160 kilonewtons climb up the ladder before it slides down? Assume a coefficient ng static friction equals 0.268 for the wall and the ground. Like always, you have to draw the free body diagram. So, bahin natin. So, let's draw, let's say, wall. Pasensya nyo na. May mas maayos na drawing dyan mamaya. Pero we have to step by step this one. So, may hagdan. May hagdan. Assume nyo lang straight in line. As always. Ngayon, yung weight ng ladder is, this is of 20 meters. And this is the weight of the ladder, which is 8 meters from the bottom end. Now, may taong papanik, let's say at this point right here. We call this point from here, this point up to this point as x. Yung distance from yung haba ng hagdang papanikin niya. They have an angle of 60 here. Ngayon, we try to think of the forces, other forces involved. Namely, yung kanina, unang discuss, yung normal force. Saka yung friction force. Kaya yung baba. Yung normal force muna tayo. Yung normal force, it is the reaction force. So, all systems have reaction forces. So, since its weight is going down, the normal force is going up sa ground. And since the force is acting to the right along the wall is acting up on the ladder. This is the normal force ng wall. Normal force 1, normal force 2. Ako, wala naman ng ibang surface na tinatouch yung ladder, so we're done. We have to check naman ngayon yung friction force. Ngayon, yung sliding motion nito is going here. Ang sliding motion yan ay pag ganyan. Siyempre, sliding motion, we can kind of imagine how a ladder would slide. Or how a stick would slide against a wall. Diba? Sliding against the wall. Ngayon, since its motion along the wall is downward, our friction is upward. And it's our sliding motion sa ground ay pakaliwa, our friction force would be pakanan. Na-gets? O magulo yung drawing?
Yes po, gets po.
Gets?
Kuha naman po.
Gets mo.
O yung pangalan na drawing, ayusin natin. Ayan. Okay. Let's say this point sa baba, we call it point M. And this point sa taas ay point E. Kasi maipilit natin yung agenda natin sa ME. You have to look at the torque along the M. The summation of force of torques along at point M. And since we are talking about the second condition, OB equals to 0. Maraming ways para isolve itong problem na to. It can also involve isang torque lang. It can involve isang torque, tapos yung summation ng f of x at f of y. But para ma-practice yung analysis niyo ng torques, we have to do 2 torques and 1 of these forces. 1, ito, 2 times natin gagawin. Para lang ma-practice natin yung analysis sa torque. Pero if you have the time, you try this one, itong method na to. Ito yung method na tinuturo sa YouTube. Pero para lang matuto tayo ng analysis on torques, we do this one. So we look at point M. Since these two forces are acting along the M, point M, we disregard. Apat na force na lang natitira natin. Yung 40, yung 160, yung normal force ng wall, yung friction force ng wall. Huwag mo natin titignan yung signs, ha? Let's do the force lever arm thing muna. Force lever arm muna tayo. May tanong? Okay. Something, I'm assuming wala. So we have this one, 40 kilonewton force. Our perpendicular distance from point M would be as 3. This one. Let's say, this is perpendicular. So, ang kailangan natin ay itong line na to. So, we have an hypotenuse ng 8, an angle ng 60. Ang kailangan natin, ang lever arm natin ay adjacent side. So, we do hypotenuse 8, cosine 60. times 40. Gets? Next one, yung 160 kilonewton ng tao natin. We draw a line straight down, perpendicular. So, ang kailangan natin ay itong distansya dito. So, we have an hypotenuse of x, an angle of 60. Ang kailangan natin ay ang adjacent side, ito. So, we have hypotenuse cosine 60. Now, yung friction force na ito ang titignan natin. The perpendicular distance would be this one. This one right here. Ito yung force. So we have an hypotenuse of 20, an angle of 60, an adjacent side ang kailangan natin. So 20 cosine 60 times friction force. And then last one for point M, normal force. Now if we extend this line here, like extending the line of action here, this is the perpendicular distance, which is equivalent from point here, equivalent to point here hanggang dito sa baba. So we have itong 20, an angle of 60. Ang kailangan natin ay itong opposite side. So we do sine. Nakuha?
Yes po.
Apo.
Ngayon, we check on the sign convention naman. You can assume clockwise is positive, pero for this one, we do counterclockwise is positive. So let's clear our board. Clear board. Tingnan natin tong 40. If we look at point M and iikot natin tong force around point M, it is in a clockwise motion. So we do negative sign. And then, yung 160 kilonewton force natin, iikot natin sa point M, we get negative kasi clockwise. Yung friction force natin, iikot natin, dikita, assume nyo lang, yan. Positive kasi counterclockwise yung motion. And then yung normal force, ganun din, positive. So now, nasettle na natin yung sign convention, saka yung formula natin ng torques ng individual forces. What we do is to make sure na mabawasan yung unknowns natin because we have X, friction force 1, and normal force 1. Ang daming unknowns. So we have the formula for friction. If you remember that the product ng coefficient ng friction times the normal force equals friction force. So we have this formula right here. Ay papasok natin to dito sa formula na ito. Kaya magiging ganito siya. In terms of Fn1. So nabawasan na yung unknowns natin. Kasi given tong coefficient natin na 0.268. What we do, kagaya na nakagawin natin, is to combine the constant and hiwalay siya sa equal sign. Ngayon, matira na lang yung negative 160 cosine 60 sa itong dalawang terms that involves the normal force 1. Para madali, i-type, simplify na natin tong 40 times 8 cosine 60, 160. Yung 160 na to times cosine 60, negative 80, negative sign. Then, we factor out yung normal force 1. Ilabas natin. Tapos pinagsama natin tong coefficient of friction, tapos yung sagot nito, then square root of 3. Nakuha? How we arrive at this equation? This equation right here. Yes? Okay. Continue. Now we check on E naman using the same same analysis thought process na ginawa natin kanina. Look at point E and the matic na forces na to cancel na. They don't produce any rotations around point E. So we have 40. Yan, ayusin natin. Yan. Ayan. Let's look at forces muna. And then their lever arms. Ang distance from E would be this one. Which is an angle of 60. Still an angle of 60 for similar triangles. And then hypotenuse natin would be 20 minus 8. Kasi from point E na start natin. So 20 minus 8, 12. But our adjacent side ang kailangan pa rin natin. So cosine 60. Then our 160 kilonewton force would be here. Similar triangles, angle 60. So we have 20 as hypotenuse, as x distance from baba. So we have 20 minus x. Pero adjacent side ang kailangan natin. Kasi ito yung perpendicular distance. So we have cosine 60. Our friction force 2 is acting here. So if we extend natin to dito, ito yung perpendicular distance. Ito yung perpendicular distance na kailangan natin. Assume straight na lang yan. So, hypotenuse na 20, an angle of 60, opposite side, 20 sine 60. And then, yung normal force 2, if we extend the line of action here, ang perpendicular distance na ginagamit natin will be this one, which is equivalent from point dito to point dito. We have 20, the hypotenuse ng distance haba ng hagdan, as angle 60, as adjacent side, cosine 60. 20 cosine 60 times normal force 2. Ngayon, we look at the sign convention ng rotation nila. Since our assumption will be consistent, as always dapat, counterclockwise is positive. So this 40 kilonewton force, rotate around point E, counterclockwise, positive. Y160, counterclockwise, positive. Friction force 2, rotate at positive. Normal force, clockwise, negative. Same process. Papalitan natin tong friction force 2 in terms of normal force para mababawasan yung ating equation, yung unknowns. So we have 40 cosine 12, 40 times 12 cosine 60. Tapos yung kanina, itong formula na to, ito pa rin. Now, what we do, i-simplify na natin yung mga terms na kaya natin i-simplify, factor out all those terms na may similar variables. So we have 240, 160 cosine 60 is 80. As distribute natin sa term na to, we have this one. And then yung similar terms na normal force 2 would be pagkasamahin natin. So we have formed this one. Given naman na yung coefficient of friction natin. So there's not a problem. Ngayon, meron tayong variable x at variable normal force 2. Lipat na natin itong constant na to sa kabilang side ng equal sign. So we will be left with negative 80x plus normal force 2 0.268 10 square root of 3 minus 10 equals negative 1,840. Guess kung paano nakarating sa equation na to, di ba?
Yes
Same
po.
process naman kanina.
Opo, yes po.
Now, we need a third equation na mapagkoconnect si normal force 1 sa normal force 2. And this would be papasok na yung first condition na equilibrium natin. Ngayon, this is tricky, pero as I said kanina about concurrent forces, yung point of intersection nila could be in turn as small as a particle or as big as this ladder right here. So this entire ladder here would be a single point. And kung titignan natin, if we draw the free body diagram na napakahaba, ang daming forces na involved. So may dalawang upward, may downward na isa. That's why we use a force of forces along the x-axis equals to 0. Dahil itong dalawa lang ang present. This one and this one. Assumption natin, kanan ang positive. So we have negative normal force 1 plus friction force 2. And then, lipat natin sa kabilang side. Or kahit wag na, nilito ko lang kayo, pwede na siyang ganito. Negative Fn1. Dito tayo agad. Pwede na siya hindi lipat. Minus 0.268 Fn2 equals 0. Pero we use this one pagka, let's say, in normal physics problems na substitute mo yung Fn1 dito para magkaroon ka na ng two equations, two unknowns. Pero since we're going to use a Calcutech again, we have to do this one na may constant tayo sa kabilang side. And yes, 0 is a constant too. So meron tayong tatlong equation, dalawa mula sa torque kanina, at isang summation of forces acting along the x. Nakuha?
Yes po.
Now, what we do, three equations, three unknowns. So, if yung EX, yung inyong model na Casio or kung ano man, find the polynomial function, tapos kung ilang unknown, ang unknown nyo ay tatlo. We have x, normal force 1, and normal force 2. Nakuha? Kayang i-type?
Opo.
Nakita nyo na. Let's say, ang assumption ko lang dito, A yung variable x, B yung normal force 1, at C yung sa normal force 2. Pero you can switch it up and the answer will be the same. Basta titignan, same reference point na titignan nyo. Ang kailangan natin kasi yung x, yung haba, yung layo ng iaakyat ni Kuyang Titan na ito, ang bigat-bigat niya, para bago mag-slide down yung hagdan. Paki-check nga kung tugma tayo ng sagot.
Sir, tanong ko lang po.
Apa?
Paano po sa FX 95ms na case of
Okay. Like I said kanina, I'm pretty sorry kung 95 ms kayo. Kasi yan ms din yung that former calculator ko, and I had to really replace kasi talagang matatanggalan kayo kasi dahil ang daming solve na involving a lot of operations like this one. Tapos, pagdating nyo ng around second year, third year, hanggang sa board exam, ito ng mode. Lahat ng functions ng ES Calculus ay gagamitin nyo na. Kaya, if kaya, invest na kayo sa cycle na matino, na ililigtas kayo hanggang sa dulo ng inyong engineering course. Pero if hindi pa rin, kailangan nyo imano-mano ito. Let's say, papasok nyo to dito, papalitan nyo to in terms nito, and then ito susubukan nyo na isama itong 2.268 na to, i-distribute nyo siya dito, and then you do solving by elimination. Let's say yung positive to, negative to, let's cancel this. Ganun sistema ang mangyayari sa inyo. Ganun ituro sa inyo ng inyong physics teacher, pero might as well have this mode 5.2 as your checker, as your ito correction then in times na you're not sure of your answer or your solution. Okay lang? Ano ko ba na-address ko?
Sige po, okay na po. Thank you.
Okay. Kung ano, kung kaya, kung may scratch paper ka na dyan, calculus, try mo na yung mano-manong algebra nito.
Yes po,
Yan.
minamano-mano ko nga.
Oo nga po. Sige, okay lang yan. Practice din yan. At as much as you can do that para ma-practice, mag-grasp mo yung concept saka yung yung concepts ng algebra na rin for practice na rin. Dahil mga physics niya ay mahilig sa solution na hindi ganitong shift solve. But since we're engineers, we need shortcuts. Shortcuts and shortcuts. Dun sa mga naka-ES at EX, tugma ba tayo na sagot?
Yes.
Yes?
Yes.
Okay. Let's proceed. Alam ko medyo masakit na sa ulo to. And it's already 11, around 11, near 11 o'clock. But we have to tackle 3 more topics. And medyo familiar naman na tayo dito sa iba. Susunod. Kinematics. Sorry kung maiiwanan yung iba, pero we have to do this. Balikan nyo na lang tong video na to mamaya if you or some other time. Kinematics, we put it simply, ito yung description ng motion. Quantitative description ng motion because it's science. We have to do it quantitatively. So ano ba yung motion? Motion is yung continuous change ng position or location at nakadepende ito sa frame of reference. Para sa physics for engineers nyo, we are tackling one-dimensional motion and sometimes two-dimensional motion in terms of projectile. Pero pagdating ng dynamics, this would be three-dimensional motion and it's gonna be a lot more harder than you think. So, alam naman siguro natin yung distance versus difference ng distance at displacement, no? So let's say this one is your frame of reference point, and you travel down a winding road. Your distance is yung total length traveled, total length of path na kinover ng isang body. So this red one, is the distance. Ang displacement would involve straight line distance from initial to final position. So if this is your final position, this would be your displacement. As in acceleration, and then acceleration. In simple terms, we have this change in velocity. And if we have some grasp on, some idea on Newton's second law, acceleration happens kapag may force na unbalance na nag-occur sa isang system. Let's say a force applied on a certain mass will produce acceleration. Kuha?
Yes po.
Medyo familiar na to kasi medyo physics nyo ng senior high, tapos yun. So yung velocity, di na natin kailangan i-expand yung definition. We all know that the velocity is a change in this displacement is over time. And the acceleration, as we mentioned earlier, is in change in velocity over time. But in terms of calculus, yes, in terms of calculus, we have the time rate change of displacement. And for acceleration is the time rate of change ng velocity. And at the same time, the same sense, we have d over dt times yung velocity kanina, this formula, dx over dt is equivalent. We're proving that acceleration is the second derivative ng change in displacement over time. And in physics, di masyadong this is only used for when velocity, acceleration, displacement is in terms of a certain function. Let's say x of t equals 30t plus 5, ganun. Yun ang gamit nito. to get velocity, to get acceleration at instantaneous acceleration, instantaneous velocity. Pero in physics, we do these three formulas na walang kamatayang kinakabisado natin, na yung final velocity is equal sa sum ng initial velocity at acceleration times time. Final velocity squared is equal sa initial velocity squared twice, that's twice the acceleration times displacement. And then yung displacement is equal sa initial velocity times time plus 1/2 acceleration times time squared. Familiar pa, di ba? Can recall?
Apa. Nare-recall.
Now, kung nare-recall na natin, naghaluan na natin ang analysis. A bank robber, ito na tayo, pag-usapan natin yung magnanakaw na to. A bank robber in an escape car, this is from my physics class in my time, but I'm pretty sure kaya niya rin to. A bank robber in an escape car is traveling at 75 miles per hour. He suddenly sees a barricade 150 meters ahead. He slams on the brakes after 0.75 seconds reaction time delay. Ang tanong, will the car hit the barricade? Kapag crash sa barricade, kung magka-crash siya sa barricade, what is the velocity just before hitting the barricade? Assume na once nag-brake, magde-decelerate siya at 4.2 meters per second squared. So let's do the analysis muna ng problem before we get into the solving part. So this is your car. Yung car mo, bilang magnanakaw, nakuha namang ninakaw mo, this is the point of time equals 0. At this point, nakita mo na yung barricade mo here. And then, however, minention na you slam the brake after 0.3/4 of a second dahil nag-delay reaction time mo. So it means na between the time you saw the barricade and the time that you hit on the brakes, may distance ka na travel. You need to find the distance first. So we given this velocity na 75 miles per hour that we converted, because in our conversion is that 1.6 kilometers is equals to 1 mile, and we know what kilo is equivalent to. And then we have the 1 hour equals 3,600 seconds, because 60 is just 60 times 60. That's why we arrive sa value ng velocity in terms of meters per second. So what we do is that we take this formula, the change in displacement over time ng velocity. So we have velocity nito, and then yung final time nakuha natin, which is 0.75 minus 0, which is just equal here. By pressing shift solve o kahit i-multiply nyo na lang, it means na 25 meters ang na-travel niya after 3/4 of a second. So knowing that the distance between sa kotse and sa barricade is 150 meters, and nag-travel na siya ng 25 meters bago nag-press ng brake, which we subtract 150 to 25, which means na dapat ang displacement natin is less than 125 meters para hindi siya mag-crash sa barricade. Ngayon, pag i-brake tayo, di ba, ang purpose natin is stopping the motion, halting the motion. So, our final velocity, syempre, is 0. Our acceleration decelerates at negative 4.2. Then, yung velocity natin kanina, initial velocity natin kanina. Our final velocity, we use this formula. Final velocity squared equals initial velocity squared times twice the acceleration times displacement. What we need is this variable right here. So our final velocity of 0, initial velocity, twice the deceleration, itong negative, equals this one. Na-follow? Kasundan? Pa-check kung tugma tayo na sagot. Around 132 meters.
Opo.
Opo.
Tugma. But para hindi mag-crash, if you remember our analysis, dapat ang displacement is less than 125 meters. However, it is not less than, it is greater than pa nga. Which means, yes po, nag-crash si Manong driver. Kawawang bangkrada na yan. What? But we have a second question. Ano yung velocity niya bago mag-crash? So we have this initial, ito na ngayon ang hinahanap natin. And then the distance na kukunin natin is yung distance from the point na nag-brake siya up to the point na barricade, which is 125. So we have final velocity na hinahanap natin equals initial velocity, same, twice the acceleration, ito, same, times yung displacement natin na 125. If we shift solve or we just find the square root of this one, ito yung sagot natin. 7.816 meters per second. Tugma?
Yes po.
Nagets naman yung analysis ng problem natin.
Opo, opo.
Okay, let's proceed. Alright, second to the last problem regarding free falling bodies. I'm sorry, pero dito pala nababago. This is why ha. Why yan? Basta you know what it means when you say free falling body. So it acts along the y-axis. We use the same kinematic equations, but magdadagdag lang tayo ng positive negative g. Positive negative g, positive negative g. Ngayon, our g that we will be using all throughout engineering would be 9.81. So, if tinuruan kayo ng physics niyo na 9.8, ang acceleration due to gravity, scratch that, because ang true value nito ay 9.806 ... And if you round this off, you have 9.81. 81. Ngayon, ang tuturo natin sa iyo paano gagamitin yung positive negative on certain problems. Ayun, imagine this one. You throw this ball upward, and it is a certain point, natitigil lang siya, then downward, hiwaba lang siya. Yung motion niya upward, which means nagdi-decrease yung velocity niya until it reaches a point of zero. So nagde-decelerate siya, which means ang acceleration due to gravity ay negative. While habang pababa siya, nag-increase yung velocity niya, so in turn nag-accelerate siya in multiples of g. Positive g. Gets?
Yes po.
Opo, gets po.
Okay. Let's use this example from our physics. So medyo chill pa tayo dito. Recall Galileo's experiment on top of the Leaning Tower of Pisa, 54 meters high. He accidentally dropped the first stone 1 second ahead of the second stone. With what initial velocity must the second stone be thrown downward for both stones to hit the ground simultaneously? Kaya niyo i-analyze on your own? Or should we do it step by step? So our silence means yes. Sige na, tulungan na natin. So this is our first stone. Stone 1 and stone 2. So we have to look into yung unang stone na walang initial velocity. So we have a vertical displacement. Yan na. Vertical displacement na 54. Tapos, since wala tayong initial velocity, this becomes 0. And then, yung gravity natin, since it is going downward, our sign convention would be positive. And then, Gravity 9.81. T squared over 2. 1/2 gravity squared. Time squared. Ngayon, if we press shift solve, it means that it will take the first stone at around 3 seconds para bumaba. Ngayon, we look at the second stone. The first stone had a head start ng 1 second. So in order for the second stone to arrive at this bottom at the same time with the first stone, kailangan ma-travel niya yung same height na to 3.38318 seconds. Ito travel niya dapat in 1 second less. Dahil nagka-head start na yung unang stone, i-make sure dapat na magkakaabot sila at the bottom. -1. So, use the same formula kanina. Ang unknown na natin ngayon yung initial velocity. Same displacement. Yung time natin na nakuha dito, -1. Because may head start yung unang stone. Same sign convention kasi downward. And then yung gravity natin. Then yung time na -1 squared over 2. Pa-check ko same time answer. 11.92 meters per second squared.
Yes po, yes po.
Okay? Many questions? Bago tayo proceed.
Always po 4 decimals, no?
Depends sa prof nyo. I mean, may habit ko na yung 3 decimals, 4 decimals. Pero it's really up to you. It depends sa prof nyo. Pero sa engineering, it's practice na dependent group. It's time. Sometimes 2 decimals, 3 decimals, 4 decimals. Depende talaga sa prof.
Okay po, noted.
Okay. Any questions pa? Baka tayo proceed. Any clarifications?
Hindi po i-apply yung yung rules po ng significant figures sa physics po.
Sig figs. It's really up to you guys. Kasi from time to time your prof, I mean, some physics teachers would use the rule of sig figs on this one. Pero pagdating nyo sa engineering ads, your profs will literally tell you what to do, how many decimal places should be displayed, how many significant figures should be displayed. So, yan. At the end, it is in the discretion pa rin ng prof nyo. What matters, as always, would be how you understand the concept. You understand the concept that needs to be done in order to solve certain real-life problems. Be it ilang significant figures pa yan or ilang decimal places. Did I answer your question?
Yes po.
I mean, yan. Okay lang naman yung sagot ko. Don't take it the wrong way. Kasi di masyado ginagamit ng profs yung sig figs unlike sa more science leaning courses. Anong questions regarding sa problems kanina? We will proceed to the last problem. Kasi last topic and last problem for our first part.
Okay po, okay.
Okay. Kaya na ito siguro, no? Law of acceleration. A equals F over M. Or, yun na, lang kamatayang force equals mass times acceleration. If you put it in in terms of words and letters, the acceleration, if an unbalanced force acts on the body, that body will accelerate. So, yung kaninang box na dinowing natin, this is a force acted upon, acceleration of a certain mass, M. The acceleration is in the same direction, yun nga, and directly proportional to the force, and inversely proportional to its mass. Walang kamatayang F equals MA. Medyo clear na tayo dyan, di ba? Medyo kilala na to sa physics.
Yes po, yes.
Apa.
Ayun, this next problem will involve lahat ng tinaral natin kanina because this problem is from my dynamics class. And you will see bakit this one involves bakit ito ay kailangan ng prerequisite na statics. and these two are just basically physics. Yeah. Shall we continue? Kakayanin natin to guys. Kahit galing to sa isang second year course, its principles are just physics pa rin. And kaya itong isolve. A small package is deposited by the conveyor belt onto the 30-degree ramp at point A, this point right here, with a velocity of 0.8 meters per second. Calculate the distance S, this one, on the level surface BC, at which the package comes to rest. The coefficient of kinetic friction for the package and supporting surface from A to C is 0.3. This will be a two-step problem involving a law of acceleration, and kinematics, to normal force, friction force, natay na natin kanina. It will all be applied here. Tingnan muna natin yung incline na EB kanina. So we have this normal force that is upward and perpendicular to the surface. And then yung weight natin na talagang vertically downward. And then yung friction force natin to the right, since ang motion natin ay to the left. We're referring to this diagram here. We do similar things. And then the incline is at 30 degrees with the ground. Ngayon, let's do summation of forces. Ang assumption natin, this time medyo nag-iba, that ang upward at leftward ay positive. So yung summation of forces acting along the Y, we have the normal force upward, and then yung weight component, this is angle 30. So we have this one downward. So this is the adjacent side. So this would be a weight, which is mg cosine. And then since this is the y component ng weight natin, and this downward, so negative, minus mg cosine theta. Ngayon, lipat-lipat lang natin, then we have this one. Simple algebra pa lang. Ngayon, we look at this one. Summation of forces acting along the x. But since the box will accelerate, di na siya in equilibrium, thus equal na siya sa mass times acceleration. Ngayon, what are the forces along the x-axis? Yun nga, yung weight, yung x component ng weight, saka yung friction force. So we have the positive na weight component, mg sine theta, minus friction force equals mass times acceleration. But we know that friction is equals to coefficient of friction times normal force. Kaya we arrived at this point. Ngayon, we combine this one, itong mg cosine theta, mapasok natin dito sa normal force na to. That's why we arrived to this point. We have a mass na di natin alam. However, all terms ng equation na to ay may mass variable. So, they don't matter. Meron tayong acceleration due to gravity, may angle na 30, coefficient of friction na 0.3, gravity, cosine theta, at 3 yung nahanap natin. Pakatry nga kung taguma tayo ng sagot. Nakuha ba? Para tayo. Around 2.36-ish meters per second squared. Acceleration. Guys, di ko yung pinagbabawala mag-participate, ha? Okay lang mag-participate, guys. It's for your benefit talaga.
Opo, nakuha po.
Nakuha.
Okay na, okay na.
Okay. Ngayon, what we need now is the velocity at point B. The point na nakababa na siya ng rampa. Meron tayong initial velocity na nagsimula siyang bumaba. Let's say this is the ramp. This is A, B. This is 2 meters. And then, meron siyang velocity as acceleration din. So now, you get this initial velocity na 0.8 meters per second squared using the formula kanina plus twice the acceleration na nakuha natin. Next, displacement, which is just simply 2 meters. Hindi ko ito muna ni-square root kasi hindi ko na siya ni-square root, pero it's up to you if you want to find the square root of this one to find the final velocity at point P. Pero kasi since the second equation would involve another value na squared, so might as well hindi ko na siya gagalawin. Pero tugma tayo na 10, around 10 yung sagot, di ba? The final velocity squared.
Opo.
Yes po.
Okay. Now, we are done with the first step. We have to analyze naman yung nasa supporting ramp. Ito. Consistent tayo sa assumptions natin kanina na upward and leftward are positive. So we have normal force for vertical forces, normal force upward, weight lagward. Okay naman, nagigets. And then next, this one. Since this body will accelerate at accelerate if it is not in equilibrium, summation of forces on x equals mass times acceleration. And then ang force lang natin ay friction force. Friction force that's acting on the right, so negative. Negative or friction force as we know it is yung mu times normal force equals MA. Then this time, ipapasok natin tong equation na buo from the summation of y forces into this one. That's why we arrive at negative mass times gravity times coefficient of friction equals the mass times acceleration. Since wala tayong mass element, mass value, we cancel mass, and then since they're in both sides of the equal sign, so they don't really matter that much. So, matitira natin is yung negative acceleration due to gravity, coefficient of friction, then acceleration. And then, simplifying, we get this answer for acceleration, which makes sense dahil negative. Dahil for sure babagal siya. Since because of friction, it will make the body slow down the body until it comes to a halt. Kaya it makes sense na negative sign ang ating acceleration dito sa part na to. Ngayon, since the box will come to halt at some point, ang final velocity natin ay 0 sa point na to. So that's this one. Then remember, sagot natin kanina na hindi natin ni square root. Kaya sakto natin siya dito. Kasi this is a point, velocity at point B. This is point C. Then, yun nga, going back twice, the acceleration na nakuha natin, this one. And then ito yung displacement na hinahanap natin, which is S. Tugma tayo na 1.7, at after 1.71 meters, titigil na yung box. Tugma tayo. Guys, okay lang? Tugma, kaya pa?
Yes po, yes.
Tugma naman.
Opo.
Yes po.
Yes. Okay. So we have come to the end of the first part. Kung may questions pa ba kayo?
None.
Kahit di sa about the none, kahit hindi sa physics, okay lang. Kahit sa buhay engineering, okay lang din.
Tanong ko lang po, may video tong recorded po ba? Ibig sabihin, pwede po siya sa drive?
Alin? Yung video?
Opo.
O sige, mamaya, tatry ko i-upload sa Drive yung video ng Calcutech nung unang dalawang problem kanina.
Opo. Thank you po.
Extend ko naman yung yung PDF version nitong PowerPoint. Pero yung Calcutech, I'm gonna presume na alam niyo na yung values. Ito yung values na to, may copy na kayo para makita na kung paano ito ina-apply sa calculator. Okay lang? Okay lang ba yun sa inyo guys?
Okay lang po. Thank you po.
Okay, may questions pa kayo?
May model po ba na na pinagbabawal po na calculator for exam?
For exam, like yung dito sa university pa lang o sa board exam?
Sa university po or sa board exam?
Sa university, wala nang pinagbabawal ng calculator kahit yung pantindahang calculator pag gamitin mo. Kung kaya mo mag-compute ng sine, cosine dyan, sige lang. Pero pag sa board exam, marami nang bawal. Kagaya nung sinasabi kong model na 991 ES, bawal as far as this tutorial is concerned, and I don't think it will change for some time, bawal to. Alam ko yung lower version nito ang pwede. Pero yung 991 ES ay hindi. Merong list ang PRC ng allowed calculators from many brands, from Casio, from Sharp, from Canon na allowed sa board exams. Did I answer question? I mean, okay naman yung sagot ko.
Apo, thank you po.
Okay.
Dapat yung 570 ES po ba, same specs lang po siya sa 991. Wala lang po siya na yung sa solar po sa taas.
Nearly same specs, pero if I remember, kulang din siya sa
Okay po, thank you po.
May tanong pa guys? Tanong pa kayo guys? Paano po yung sa CalQ?
Yung sa assumption po ba dun po sa torque, yung sa counterclockwise po saka sa clockwise, paano po magki-create ng assumption?
It is up to you. Ikaw magse-set nun. You are going to set it yourself. Ikaw mag-set ng sarili mo. You have to set it yourself. I mean, pwede natin i-assume siya ng clockwise. I will still arrive at the same answer. But as long as you're consistent sa iyong assumption on the direction, on the rotation, it will be fine. Consistency lang talaga para hindi kayo maligaw ng landas sa pagsasolve.
Bali po madedetermine po kung clockwise or counterclockwise, depende po dun sa point ng, di ba po dun po sa point M and E? Dun po siya i-determine.
Depende siya sa point M and point E.
Okay po. Thank you po.
Okay. Aling Jobert yung tanong mo? Aling part sa Calc? Ay yung Calcutech? Yung sa Calcutech ba? Yung sa Poly? Hindi ko mahanap. Ano po ba yung model mo, Jobert? Model ng Calc niyo? Brand and model na rin. Pag nakita niyo po sa model na MS siya, I can't help you, but you have to do it mano-mano talaga. 991EX. Teka. Pinas mo na yung menu? (991EX). Jobert, na-press mo na yung menu. Katabi lang siya ng on button. Yung sa kaya yung Simon equation, nakuha ni Patrick Mauricio. equation or function po at Simul equation. Yun. Sa sharp ata yung polynomial, pero doon sa Simul equation yun. Doon sa 85BS, this works the same din. Check mo yung mode. Katabi ng on button. Doon sa 85. Jobert, nakuha mo na. Nakita mo na yung Simul equation. Sa 85BS, 5. Mode 5. May 5 ba dyan? Nakita mo dyan yung equation. Hanggang 3 lang. 1, 2, 3. Kaya ba ng 85 PS? So, teka.